All right, as we get started today, I want to continue looking at what we started talking about yesterday, and that was one of my favorite things in trig, and that's solving trig equations. So like a regular equation where we're solving for x is equal to some specific value, here it's actually theta that's going to equal a specific value, Jamie. And we're looking for often multiple theta values, and the key, just like in solving an equation, is to get the x by itself. In a trig equation class, the key is to get a trig function by itself. And once you've got it by itself, then you'll ask yourself, okay, when does this trig function equal this? You'll have to account for quadrants, remember, right? ASTC, when is it positive, when is it negative, and get all the positive whatevers, right? We'll take a look at one here in a moment. We also said if there's multiple trig functions, we don't ever want to divide away a trig function. Rather, class, we should set it equal to 0 and factor. What do we do if there's multiple trig functions?
Set it equal to 0.
Set it equal to 0 and factor. Let's look at number 13 on page 141. And this one requires a little bit of creativity. We have the cosecant squared eta minus the cotangent eta minus 1 all equal to 0. Here, of course, we see multiple trig functions. So the strategy class would be to and
factor.
Yeah, set it equal to 0 factor. The problem is, it's already set equal to 0, but I can't really factor that. There's nothing that factors. There's no common factor. There's no ability like a quadratic. We've got a squared first gone, but one's a cosecant squared, one's just a cotangent. Thoughts, Chris?
Change cosecant to 1 over sine, and then change cotangent to sine over cosine.
That actually will work. So what we used in identities where we could change the sines and cosines, you could do here. There's a much easier way, but it's not wrong what he said. No, I'm not going to like that on the back end, though. I don't think.
Cosecant squared equals 1 plus cotangent squared?
There we go. The other way is look at the other functions that's with it, right? And for instance, if cosecant squared were with, say, a sine or something, I would be thinking sines and cosines. Or if this were a, maybe this is a, I don't know. But we got cotangent, we have cosecant squared. I would use the Pythagorean identity 1 plus cotangent squared eta equals cosecant squared eta. That's just going to be a little bit more direct for us. Does that make sense? I think we may be able to get the other way and get to the same point. This is going to be, I think, a lot easier for us.
I never remember that Pythagorean function.
That's the problem.
I know it, but it doesn't come to my mind when I see it.
Okay, it's got to. It needs to. We see squared, we need to think through all 3 Pythagoreans, right? When we see squares and ones especially. So thoughts at this point, speaking of ones, Ethan.
Cancel.
Yeah, they cancel. And now do you see, I do have the ability to factor now. I can factor out Quentin. I don't factor out Quentin, but factor out a cotangent eta to be left with what in parentheses?
Cotangent eta minus 1.
There we go. And now that I've got both factors, I'm going to set each factor, Chris, equal to
0.
To the 0. So we'll say that the cotangent of eta equals 0, and the cotangent eta minus 1 equals 0. But Chris, that means the cotangent eta is going to equal positive 1. I said we always want to make these ratios by putting them class over 1. I said you want to make sure you're attentive to what SIGN is present. On a 0, for instance, class, we know there's a technically nothing, so we could view it as both positive and negative. For here, the 1 over 1, it's positive. And then you're going to ask yourself this question. When is cotangent 0 over 1? Well, what triangle does that have to be in class? 0, 90, 90, right? You know it's either 0 or 90. The question is, when is the, let's see, what's cotangent? Whatever what? Adjacent over opposite, right? When is adjacent 0 and opposite 1?
90.
At 90. Or you use the unit circle, and 90 degrees, the cotangent line is 0 at the 90. So we've got 90, but because of the positive negative, we have both positive 90 and, if you will, the negative of 90, which would be 270 degrees. The opposite of the 90, right below it, would be the 270. And then here, cotangent eta is 1 over 1. Well, again, cotangent's 1 over what? Adjacent leg over opposite leg. When would both legs be 1? 45. And we got the positive, okay? When is cotangent positive?
quadrant 3 and 1.
3 and 1. So we want the 45 and 1 and the 45 and 3. What's the 45 and 1?
45.
Obviously. And what's the 45 and 3?
225.
225. Do we remember doing this yesterday?
So how did you find out it needs to be in the third one?
Well, when is cotangent positive? ASTC. The A and the T.
And how did you know it was supposed to be positive?
Because there was an understood positive. Yep. Yep, good question. All right. Just don't. Basically, a reminder: don't forget about understood positives. Right. Make sure we write those in to help us with the ASTC. Questions on these? I've got 4 of these I want you to do. If you would work on pages 140 to 141, numbers 1, 5, 10, and 12. Take a few minutes to work on these. Number 1, number 5, number 10, and number 12. Again, use the unit circle or use your special triangles, including the 0, 90, 90 triangle, to help you solve these. Once you've finished, pencil it down and cut this way. Quentin's finished. Chris is finished. Just a couple more minutes to be finishing that up. just another minute or so to be finishing up. All right, put your pencils down, and let's go and take a look at these. If you're watching on YouTube, you need a little bit more time. You can go ahead and pause it, but students in here can't pause me, so we're going ahead. Let's go ahead and take a look at number 1. Let's start with Ethan. What did we need to do here?
Divide the two away.
To get the sine of theta equals, and we've isolated the trig function. So just like that, we ask ourselves, when is
1/2. It's 30 degrees.
when is sine a half? Right? When is opposite over hypotenuse half? And the answer is, as he says, 30 degrees. But there's also an SIGN here. What SIGN is present?
Positive.
When is sine positive?
Quadrant 1 and quadrant 2.
So we need the 1 and 2 forms of 30.
30 degrees and 120 degrees.
Remember, we always measure off of the x-axis, so we come up 30.
150.
150. Remember, anything off of the y-axis is a co-function, and we're not doing anything with a co-function, so we're going to leave the y-axis alone. And this chapter, we're really not touching the y-axis, so we're going to go off the x-axis. How many have 30, 150 as your answers? Questions?
Yeah, I had the 30, I didn't have the 150. How did you find the 150?
When is sine positive? Quadrant 1 and quadrant 2. Don't lose your quadrant 2 form of 30.
Like from quadrant 2, how do you judge that it's 150? I thought it was 90. That's why.
In quadrant 2, everything, until we talked about same function, co-function,
Oh, it's 180.
everything
Yeah.
comes up, off, or down off the x-axis. 30 here, 30 here, 30 here, 30 here gets 30, 150, 210, 330. The only time we've ever come off the y-axis is for a co-function. We're not doing anything with a co-function. Make sense?
Yeah.
So come off the x-axis for your angles. Number 5, I see multiple trig functions, Jamie. And when I see multiple trig functions, what are my keys?
You set equal to 0 and factor.
Thoughts?
Can't factor, but you could set both of them equal to 0.
It's already set equal to 0 and it's already factored. So what will I do with each factor?
So 0, and for the first one it'll be secant of alpha equals -1, and cosecant of alpha equals 2.
Or if you move the cosecant over, cosecant 2 equals cosecant. Same thing. In each case, class, we need to make a ratio. 1/2 was already a ratio. Here we're going to put them over 1. And again, it would help if you're a triangle person to think secant is whatever what, class? Hypotenuse over adjacent. It would help to think that cosecant is whatever what?
Hypotenuse over opposite.
So you can picture your triangles. If you're a unit circle guy, you're just picturing the secant line. Or you're picturing the cosecant line. And asking yourself, when is the secant 1 over 1, class?
45.
90. There's 0.
0. Adjacent, 0, 90, 90, which we know we're in, right? We know it's a 0, 90, 90. We know we're going to have a 1, 1, 0, but when is the adjacent one? Adjacent is 1 for the 0 degree. Right? So we've got a 0 degree, but it's a negative. So we want only the negative or opposite of 0 degrees. What's the opposite of 0 degrees? So here, alpha is 180 degrees. Coming over here, when is the cosecant 2 over 1? Hypotenuse over opposite. 30 degrees. But there's an understood positive. Which quadrants is cosecant positive, class?
2 and 1 and 2.
1 and 2. So I need the 1 and 2 forms of 30 again.
30 and 150.
30 and 150. How many got this one correct? Questions?
Got half of it.
I'm sorry? Got half of it? All right, questions. Now, here's a strategy tip for you. You ready? I'm a unit circle guy, and if you're watching your unit circle, if you like the unit circle, you hate secant and cosecant. Agreed? Those are the most annoying functions on the unit circle. I love sine and cosine. I got my sine, I got my cosine. I even like tangent okay. Make it a cosine. Flip it. Make it a sine. Flip it. Now I get to picture my cosine line and my sine line. And if I cotangent, I don't have cotangent, but if I cotangent, I can flip that and think of my tangent line, right? So you can always flip them to go back to your sine, cosine, tangent, your big three if you wanted to help yourself with that. But anyway, questions? Let's take a look at number 10 next. And Quentin, we've got the 3 tangent squared phi equals 3.
Divide away 3 and then take the square root.
To get,
Tangent phi equals 1. Or
you divide by 3 to get 1, but when you take the square root to cancel away the squared, what are the square roots of 1?
positive, negative.
And it's your idea to take the square root. Don't lose your positive, negative, which means ASTC, which quadrants are we in? All 4. And if you don't remember the positive, negative, you're going to lose 2 of your answers. Does that make sense? When is tangent, opposite over adjacent, 1?
45.
And all 4 quadrants we would have?
So 45, when 25, 135, 225, 315.
And these should have been our answers. I assume you have the 45 and 225 because you forgot your positive, negative. How many have these answers on number 10?
I had 2 of them. I have a question.
Yes, sir.
The only reason I only had 2 of them is something to be positive, negative. I only had positive. And then
Don't forget positive, negative when you take the square root.
Square to 1 plus, or secant squared minus 1.
Oh,
And I moved over the 1 as a positive.
Oh, my.
Which turns
You got the
to
same answers.
Which turns it to 2 to the square root, which I should have did.
You pulled a Quentin.
And then secant equals square root of 2 over 1.
Technically positive, negative, right?
I'd have had positive. So.
But
I
by
had
changing to
45.
the Pythagorean, you would have had quadrant 1 and quadrant 4.
I just forgot to do the.
And again, they're forgetting the positive, negative. Again, if you do it correctly, you do get the exact same answers, don't you? So what Ethan was saying was he changed this to secant squared phi minus 1 because, you know, he pulled a Quentin, right? Added the 1 to get 2, took the square root, but again, because he forgot positive, negative, secant's equal to the square root of 2 over 1, but he's only dealing with quadrant 1 and 4 because of the positive square root, which again, you're like, well, those are different answers. Right, but if you did it correctly and remember the positive, negative, and if Quentin does it correctly and remembers positive, negative, both of them have the exact same answers. So it's not wrong to take the long way, as long as you do everything perfectly. But you have to do everything perfectly the short way too. All right, questions on this? Interesting thought. All right, questions? All right, let's take a look at number 12 last of all. And Chris, what do we need to do here?
Set it equals 0.
Good. By moving the
Negative sign over its positive sign.
to get
Cotangent times sine plus sine.
cotangent theta sine theta plus sine theta equals
0.
all right. Then what?
I changed the cotangent to cosine over sine.
Oh, don't do that. Don't make it harder, Chris. We set it equal to 0 and we
Factor.
factor. We don't change stuff and cancel stuff, because then it gives you cosine plus sine, and you lost a sine, now you don't know which way is up. No, my friend.
Pull out
Just
a
factor out a sine. Leave yourself with, in parentheses,
cotangent plus sine.
cotangent theta,
Sine.
you pull a sine
One.
out,
One.
plus 1. And you set each of these equal to 0 to get
Sine equals 0.
sine theta equals 0.
Cotangent theta plus 1 equals 0. Will really would equal -1.
In both cases, put them over.
1.
And in this case, let's go ahead and put a,
Positive negative.
because it's neither, we could think of it as being both. When is opposite over
90
hypotenuse
degrees.
0 over 1?
90 degrees. 0 degrees.
0 degrees. But we need the positive and the negative. Don't be lazy. Draw the triangle. Again, it's not a guesswork game. It's a knowledge game. You know 0 is across from the 0. You know the other two are 1s. Opposite is 0. It's got to be the 0 degree, but we want both of them. So we're going to say theta is.
0.
And what's the opposite of 0? What's directly opposite 0? 180. Just like what's exactly opposite 90, class?
270.
270. All right, then we come over here. We got the cotangent's equal to negative 1 over 1. Cotangent's 1 over 1.
Adjacent over opposite.
There we go. So we need both legs to be 1.
0 degrees.
One of these is a hypotenuse. Both legs need to be 1.
45.
There's your 45, but it's negative. When is cotangent negative?
2 and 4.
So we need the 45s that are in 2 and 4.
Okay. So 135 and 315.
And there we go. How many of these answers? For number 12. Right? Questions on number 12? Feel like we understand it a little bit better now that you've had a chance to try it on your own. Again, my regret is we didn't get to do these problems for homework last night, which we should have, but with Wednesday homework policy we didn't. But that would have been good for you to have had the chance to practice them last night. Well, it was a little fresher in your mind, but regardless, getting the chance to practice, even if you don't get it correct, hopefully helps you understand it a little bit better. Do we feel like we've got it now? All right, let's take a look at some maybe a little bit more advanced problems, or a little weird problems. Number 18's got a little bit of a twist to it. Thoughts on number 18, anyone?
Yeah, move 3 over.
Why?
So you have to say equals 0.
Why? There's a word I'm looking for. It starts with a Q.
Quadratic.
It's it's quadratic, right? So that's why we want to set it equal to 0. So you're right. Let's send the 3 over as a
-3.
-3. And once we set it equal to 0, class, then we factor. Ooh. But it's not a common factor that we factor. What are we going to do to this thing?
Back.
What would we do to that thing?
Backwards 4.
Backwards FOIL. Well, we've been working on Algebra 1 lately. We're going to backwards FOIL this thing. If it were an x squared class, and we'd split it up into x and x. It's a tangent squared phi, so we're going to split it into tangent phi. Negative sign tells us signs are different. They alternate. One's positive, one's negative. The only way to split up a 3,
1 and 3.
1 and 3. And remember, we always check our outer inner.
No, that's not right.
Okay, so change the sign. Make that the positive, and make that the negative. Now the outer inner checks, right? And then set each factor to 0. So you get that the tangent of phi is equal to 1. And we get that the tangent of phi is equal to -3. In each case, make them ratios.
Over 1.
And I'm going to go ahead and write the positive that is understood here. There, I don't need to put a sign because the negative is already there. Here, let's put the positive. Opposite over adjacent. When is tangent 1 over 1? 45 degrees. And positive, when is tangent positive?
3 and 1.
Only 3 and 1, so
215.
No, 225.
225. Questions on the first two answers? Now we come to the next one. Opposite over adjacent.
No, so
It can never be.
Hold on now. Can you have a leg of 3 and a leg of 1?
Yeah.
Sure, but it's not a special triangle. Remember, tangent goes up to infinity, down to infinity. Remember? Whoop, asymptote, whoop, asymptote. Remember? Tangent can be anything. So if sine were -3, no. Sine only goes up to the 1, down to the -1, remember? This is one of the reasons why we graphed it. So you help picture this, right? Tangent can be anything. So it's not that there's no solution, but it ain't special. Here you're gonna have to use your calculator. We're gonna have to take the arctangent of both sides. And let's just do 1 decimal place here. What do we get when we take the arctangent of, forget the negative for a minute, and this is a strategy tip, you might want to jot this down. When you're using your calculator, ignore the negative, just like we did here. We just said, okay, when is tangent 1 over 1? Okay, now, when is it positive? When is tangent 3 over 1?
71.56.
71.56, blah, blah, blah. Okay, now, when is tangent negative?
Quadrants.
2.
All right, so in quadrant 2, I'm going to do 180 minus that. If you want to put it in the memory, you can. What do we get?
101.43.
Ooh.
Or 108.
108.43. We'll say 108.4 degrees. Actually, we should do as an approximately equal to. And then quadrant 4 is going to be 360 minus that.
It's 288.11.
288.4 degrees. It isn't going to happen often that you need your calculator. But every now and then, and that's what we see here, yep, we're going to need it. And there we did. Questions on this? The first difference is we haven't backwards foiled in a long time. It's been a while, right? So backwards foil, get a refresher on that. And then also how to use the calculator if it comes up again. I would ignore the sign, the SIGN, get the reference angle, maybe put that in the memory value, then get your quadrants, figure out what your answers are. Questions on that? All right, let's take a look at number 20 now. Number 20, we have a 2 cosine phi positive secant phi equals 3.
Why don't you put secant as 1 over cosine?
Here, Chris, I was actually going to call on you. Here, that's a wonderful idea. Why is it so wonderful to put secant as 1 over cosine, class?
They'll cancel.
You're on a roll. There's another cosine in the problem, at least, right? Earlier, Chris, where you wanted to do 1 over sine squared, but there wasn't another sine anywhere in the problem. Well, here there is another cosine in the problem. So by writing this, doing this with me, as 1 over the cosine, makes a lot of sense, because now at least there's all one continuous trig function. Does that make sense? But there's also a fraction. And I hate fractions. In fact, when we create a fraction, we need to specify that that denominator class cannot equal 0. And just leave that little fact there till the end. Write it down. We're going to put it out of our mind for a little bit and just solve. I see fraction. I hate fraction. I multiply everything. Thank you, Ethan. By the LCD, which is, of course, if I multiply everything by a cosine, here, class, I get
3 cosine.
2 cosine squared phi. Here, when I multiply the cosine, it's going to cancel, so I just get a 1. And then here I multiply by a cosine.
3 cosine.
3 cosine. Now I've turned what was weird looking to a quadratic. A complete quadratic. Set it equal to 0. So let's pull this over to get what, Ethan?
2 cosine.
Head off hand?
2 cosine squared phi minus 3 cosine plus 1 equals 0.
And I guess what we're going to get to do again, class. Just in case one problem wasn't enough review for you, let's do another one. Backwards FOIL, here we come. And we'll split the 2 cosine squared into...
Cosine squared, cosine squared.
Oh, not cosine squared, cosine squared. How about 1 cosine and 2 cosine? Right? If I did 2x squared, we go 1x, 2x.
Yeah.
Well, we got a 2 cosine squared. 1 cosine, 2 cosine. My signs?
Negative.
Both negative. The only way to factor a 1?
1.
Does the outer inner check?
Yes.
Yes. By the way, what if it didn't?
Then you don't have a solution.
Then we have the quadratic formula, or we have completing the square. Oh boy. All right. Private factors. All right, because we got backwards FOIL, but the other two, it's going to take a little bit of review when we get there. If we get there. All right, let's take a look at these here. I'm going to make two little equations out of these as I get these trig functions by themselves now, Jamie. Smart.
Cosine phi equals positive 1, and we do cosine equals 1, but you'll have to divide by 2 to get 1/2.
I like you said positive 1, like positive 1/2. I'm going to make this positive 1 over 1, in fact. All right, what is cosine in both cases, class? Adjacent over hypotenuse. And an adjacent of 1, adjacent leg of 1, and a hypotenuse of 1 also.
0 degrees.
0 degrees. But, and notice just positive. So not 0 and 180, just.
I have a question. So, have you done this so much that you've memorized, like you can just look at that and know exactly what the angle is? Just from, not from knowing the triangle necessarily, just from doing it over and over?
I generally key in on the opposite. And I'm like, adjacent, hypotenuse, so the missing one is the opposite of 0. What's always across from 0 is 0. That's how my brain ticks. Not everyone. Or if I'm unit circle, the cosine line's horizontal. Well, when is a horizontal line a length of 1? Well, that's at the radius, which is 0 degrees. Anywhere else, that cosine line comes in. So there's a couple ways you can look at it. That's how I look at it. Over here, when is the cosine of half?
You realize you were sitting down.
When's cosine of half, class?
For a 30-degree angle. No.
60 degree angle, right?
I'm gonna cry.
And so just positive, but cosine is positive 1 and 4, so 60 and
2, 3, 1. 300.
300. Now, one little caveat. Cosine can't be 0.
So,
For any of these angles, if you took the cosine of those angles, would you get a 0? No. When you take cosine of that, you get 1. When you take cosine of that, you get half. Take the cosine of that, you get half. No. Okay, so no, for none of them does cosine equal 0, but it's just something I want to remind you is up there to check at the end. Questions on this one? Questions on backwards FOIL? Questions on when to use reciprocals? This is a perfect time. Questions? All right, let's take a look at number 21 next. Oh, this is a joy. Secant of sigma times the secant of sigma minus 2 times the secant of sigma plus 1, all equal to -2. On one hand, you're like, oh boy, it's already factored for me. But the problem is it's not equal to 0. And if multiple things are multiplied and equal to 0, you know one or all of them have to equal 0. But you don't necessarily know that all of them have to equal -2. So some students will drift from what they know to be true, and they're like, oh, I'll just set them all equal to -2. That is not how this works, young person. Instead, we're left having to actually multiply the whole left side together. Let's start with the FOIL, and we'll distribute the secant sigma later. First, outer, inner, last. What's the first? Secant squared sigma. Outer, inner. -1 secant. Last.
Is that one important?
It might be. Last.
-2.
-2. More just so +1, -2 gives -1. So because I was saying it, I went ahead and wrote it. Normally I wouldn't. You're actually right. All right, next thing. You got to distribute. To get what?
Secant cubed minus secant squared minus 2 secant. A lot of secant.
All right, well, no, because we're not ready to factor. You don't factor until you've set it equal to 0. If we were going to pull out a secant, we'd be right back where we started. I think you realize that. Hence the
That was
laugh.
the joke, yeah.
Yeah. All right, so I need to set it equal to 0. Now let's move the 2 over as a positive 2. And now it's all equal to 0. But now, when it comes time to factor,
I remember something about that.
there's 4 terms. Set it equal to 0 and factor for quadratic or higher powers, but there's 4 terms. How do we factor 4 terms?
Find out squared.
Grouping. Let's review grouping, shall we? We look at the first 2 terms as a little group. We look at the last 2 terms as a little group, and we ask ourselves, there's nothing common to everything, but in the first 2 terms, what is common in that little group?
Secant squared.
A secant squared. And we factor out a secant squared sigma just from that little group to be left with
Secant minus 1.
secant sigma minus 1. In the next little group, what's common?
2.
But we always take the sign of the leading term. The leading term has a negative. So let's factor not a 2, but a negative 2. When you pull a negative 2 from the negative 2 secant, secant, and negative 2 from positive 2,
Minus 1.
negative 1. Now, I have, instead of 4 terms, I now have 2 terms. Secant squared, secant negative 1, negative 2, secant negative
And then you
1.
make the first in the middle of 2.
And what's common to both terms?
Secant minus 1.
The binomial common factor, not monomial like we're used to, but a common binomial secant negative 1. You're doing this with me. Just in case you needed that reminder. What am I left with in parentheses when I pull out the secant negative 1?
Secant squared sigma minus 2.
Secant squared sigma minus 2. And now, I have set it equal to 0 and factored. What a pain. All right, but we got it. So now, I can set each factor equal to 0. That was the whole point of setting the whole thing to 0, and factoring was to set the factors to 0 to get 2 little mini equations.
Secant equals 1 over 1. And then secant equals 1 over 1.
Positive, negative, square root 2.
You move that 2 over, you have to take the square root of it. It's going to be positive, negative. Good, Quentin, learned from your mistake earlier. Square root of 2, and I'll put that over 1. All right, here we go. Secant, positive 1 over 1. Secant, positive, negative, square root of 2 over 1. Secant in both cases is 1 over what?
Adjacent over, or hypotenuse over adjacent.
Hypotenuse over adjacent. I need a hypotenuse and an adjacent leg to both be 1. 0. Just positive, so just plain 0. Not 180. That would have to have a positive negative. When is secant, hypotenuse over adjacent, square root of 2 over 1?
60. 45. Oh, wait.
Square root of 2? 45, right? Hypotenuse of square root of 2 is like 45, 45, 90. But I want positive, negative, which means all my 45s, right? So,
45, 225, and 315.
and there we go. Questions on that ghastly thing? Grouping, something else from algebra we hadn't reviewed in a while. So, here's a perfect opportunity. Let's take a look at number 22. All right, Christopher, here we go. I have a sine chi, cosine chi, minus cotangent chi, all equal to 0. What should we
Are
do?
you saying it's my time to shine?
It is your time to shine.
Put the cotangent sign over cosine. Wait, no, you told me you're trying to fix it. Alright, let me write it on my paper first.
Good idea. Let's do that. Then we'll shine.
Alright, let's see.
Shine like a teenage boy's face.
I really think cosine over sine would be.
I think so too.
I said that.
You said sine over cosine. Cosine over sine. I was letting you correct yourself and see that yes, we really do want sine and cosine stuff from this, cosine over sine in this case, because there's other sines and cosines. So yeah, this is another time where that quotient identity is perfectly used. Make sense? Okay, and again, are you starting to see when to pull it out? Not always, but here's a great opportunity. And then, because we created a denominator class,
Well, third, can't equal 0.
sine chi cannot equal 0. Just tuck that there. We may need to come back to it. Then let's get rid of the fraction by multiplying.
Everything by the LCD.
There we go. And we multiply everything by sine. What do we get here?
Sine squared, cosine, and then minus, you cancel, so just cosine, and then equals sine. No, 0, it equals 0.
Good. All right.
Factor out
Pull out a cosine.
Pull out a cosine. Tell you what, Jamie, I haven't heard your voice enough today. Jamie?
Well, let's go sine squared minus 1 in parentheses.
Good.
But that just equals cosine.
Actually, it would equal negative cosine,
cosine.
but I don't want to confuse the issue and do more work than I have to, because this is actually not a hard step that's coming up next anyway. Move this further away. All right.
So set them each equal to micro like fraction or micro.
Say equals
How about
0.
set equal to 0? And we'll say that cosine chi equals
0.
0 over 1. I'm going to put the positive negative and say that sine equals, be careful,
Positive negative square root.
which is
1.
what? Positive negative 1 over 1. All right, here's a question. When is cosine adjacent over hypotenuse 0 over 1?
90.
90. We want positive and negative forms of 90.
So 90 and 270.
When is sine opposite over hypotenuse 1 over 1?
0.
90.
No,
90.
90.
Yeah.
And I want both 90s.
So
They're already here.
90,
Yeah.
we
I'm too
got-
lazy to rewrite it. Now, for either of these angles, would the sine equal 0? No, for both of these, the sine equals 1. We're good, but again, it's good to come back to that and check because the time you least suspect it is when you're going to get burned. Here's my 2 answers. Questions on this problem? All right, well, we had a lot more to get to, but we're out of time. Some pizza day thing these kids made up.
You know we made it up.
Some people's kids.
It'd be great.
All right. Well, let's do for homework. Page 140 to 141. Pages 140 to 141. Numbers 3, 11, 14 through 17, 19, and 23. So 8 problems for homework tonight. 3, 11, 14 through 17, 19, and 23. Hold on, and you'll be dismissed in just a moment.